Good day, sir. Our topic that we discuss is all about the hydraulic and pneumatic accessories. So first, we discuss about the hydraulic reservoir. This is the hydraulic reservoir is a container for holding the fluid required to supply the system, including a reserve to cover any losses from minor leakage and evaporation. The reservoir can be designed to provide space for fluid expansion, permit air entrained in the fluid to escape, and to help cool the fluid. So mao na iyahang purpose kibali sir nga kani magtabon siya para walay makagawas nga mga fluid. So mao na iyahang main purpose sa hydraulic reservoir. So ang iyang size, a rule of a thumb for sizing a hydraulic reservoir suggests that its volume should equal 3 times the rated output of the system's fixed displacement pump or mean flow rate of its variable displacement pump. This means a system using a 5 GPM pump should have a 15-gallon reservoir. So how to fill? The hydraulic reservoir, open the hood and locate the hydraulic reservoir. It will have a vented fill cap with a sight glass or fill gauge on its side to indicate the fluid level. Provide the fluid, remove the vented fill cap, and insert the oil into the fill tube and begin pumping the liquid into the reservoir. How to clean a hydraulic reservoir? Drain the system when the fluid is still at operating temperature. Carefully check the system and drain it until empty. Number 2, clean the reservoir. Number 3, flush with a low viscosity fluid. Number 4, bleed and pump the vent. Number 5, test the pump. Number 6, start the pump. Number 7, refill and test the reservoir. And last, test for system stability. Hydraulic accumulators. Hydraulic accumulators are energy storage devices. Analogous to rechargeable batteries in electrical systems, they store and discharge energy in the form of pressurized fluid and are often used to improve hydraulic system efficiency. An accumulator itself is a pressure vessel that holds hydraulic fluid and a compressible gas, typically nitrogen. The housing or shell is made of materials like steel, stainless steel, aluminum, titanium, and fiber-reinforced composites. Inside, a movable or flexible barrier, usually a piston or rubber bladder, separates the oil from the gas. So sa sulod yan ning hydraulic accumulators na gyud siya katong murag guma sir para ma-separate yun ang oil o ang gas para dili magsagol. So na 3 types sa accumulator gas charge. Number 1, bladder accumulator. This is the most popular and it features as fast response, less than 25 milliseconds, a maximum gas compression ratio around 4:1, and a maximum flow rate of 15 liters or 4 gallons per second. Although high flow versions up to 38 liters or 10 gallons per second are available. It also have a good dirt tolerance. They mostly unaffected by particle contamination in the hydraulic fluid. So mo ni ang kibali kasagaran ginagamit karon kaning bladder accumulator. Number 2 is piston accumulator. This can handle much higher gas compression ratios up to 10:1 and flow rates as high as 215 liters or 57 gallons per second. Unlike bladder accumulators, whose preferred mounting position is vertical to prevent the possibility of fluid getting trapped between the bladder and the shell, piston accumulators can be mounted in any position. So ang iyang ang naka-advantage aning piston kaysa dito sa kaduang sa bladder sir, kani ang pwede siya og maun sa iyang position, unlike sa kadung isa nga kinhangan gyud nga naka-vertical ra gyud siya. So kaning piston accumulators also require a higher level of fluid cleanliness than bladder units, especially at lower pressures, and exhibit hysteresis. So kinhangan po ni siya, naka-disadvantage po ani niya kay kinhangan siya og kanang hinlo gyud siya. Hinlo nga fluid. So mao ni siya ang kaning sa first sir, mao ni ang bladder accumulator and piston accumulator. So number 3 is the diaphragm accumulators. Have most of the advantages of bladder type units but can handle gas compression ratios up to 8:1. They are limited to smaller volumes and their performance can sometimes be affected by gas permeation across the diaphragm. So mo ni ihang picture sir. So diri na pod sa hydraulic coolers and heat exchanger. Hydraulic systems use heat exchangers to control oil temperature and therefore viscosity within an optimal range where the fluid has the best combination of properties useful to the components of the hydraulic system. Although a few hydraulic machines can make do without external cooling such as small low-duty or load-sensing systems, most require a device to keep oil in its ideal temperature range. This is where heat exchangers come in. So kinahanglan gyud ni ang kaniang heat exchangers para sa pagkontrol sa oil sa sasakyanan o sa iyang temperature pod. So what a heat exchanger does is self-explanatory. It will use a fluid such as water or air to transfer heat into or away from hydraulic liquid. Very simple. However, the nature in which heat exchangers transfer heat can vary vastly. Liquid to air and liquid to liquid are the two primary types of heat exchangers, and you can imagine they can use air and water respectively to remove heat from a hydraulic system. So ang ilang kibalik ko ani vice versa sir, liquid to air or liquid to liquid. Liquid to air coolers transfer the heat from the hydraulic fluid through radiation and convection. The simplest liquid to air coolers are radiators that count on the thermal difference between the hydraulic fluid and the ambient air. The rate in which a heat is removed from the oil is factored only by the temperature difference between the air and the oil, or the higher differential means more cooling, and by the existence of airflow, which is sometimes likely in a mobile application.
So let's continue the topic. So next is hydraulic fluid. Hydraulic fluid is the energy transfer medium in all hydraulic systems. However, the job of hydraulic fluid goes beyond simple transmission of power. Although transmitting hydraulic energy is the core purpose of hydraulic fluid, it is useful in four secondary functions: heat transfer, contamination removal, sealing, and lubrication. So the main purpose of hydraulic fluid is to make the system kanang dili siya overheating sa mechanism sa sulod sa machine. So na siya four secondary functions. So ang heat transfer, contamination removal, sealing ug ang lubrication. So mao ni ang lubrication, mao ni siya ang katong padanlog sa mga parts dito sulod. Nya mo ning kaning contamination removal. So ang kaning kanang mao ni siya ang dibali ang hydraulic fluid mo'y dahilan para kaning contamination sa sulod nga mga minerals mawala, ma-remove. Nya ang kaning heat transfer dibali ang kainit sa sulod i-transfer niya ba. Then kaning sealing, so isa po ni siyang hydraulic fluid para walay leaking nga makuan bitaw. So masil niya tong mga bangag dito sa sulod. So next, so heat transfer. Hydraulic machines produce a lot of excess heat in normal operation, often caused by inefficiencies of components themselves, like pumps and motors. Without a way to carry heat away from these components, they could easily overheat with resulting damage of seals internal components, especially as a result of local viscosity. As oil returns to the reservoir, it is often passes through a cooler to help maintain optimal temperature range before it is pumped back out to the system. Conversely, hydraulic fluid can carry heat into a system during cold starts when needed. So pasabot na yung heat transfer. So mao ni nagiingon diri nga ang fluid mo siya may dala sa heat padong dito sa system during sa kanang cold start. So mao ni siya ang main purpose aning heat transfer. So next, contamination. If closed loop hydraulic system didn't bleed of fluid at a control rate, contamination would quickly accumulate to critical and damaging level. Heat can be considered a form of contamination, but hydraulic fluid also carries particles of water away from sensitive components through filters or other conditioning devices, where it is cleaned up and returned to the circuit. Oil without impetus would remain within sensitive components, allowing essentially trap contamination to slowly destroy its surrounding. So kaning contamination, so kung closed loop daw ang hydraulic system nya didn't bleed of fluid at control rate, so magrabihan ning ang contamination ani. So magresult siya sa critical damage or critical and damaging level. So may gani kaning hydraulic fluid, so nani siya isa ni siya sa na siya kanang principle nga makapabugnaw sa init dito so kay giingon man diri nga ang heat kay one of the kuan daw consider naman siya sa contamination. So mo ni ang trabaho pa ning hydraulic fluid, so isa pa ni siya mapabugnaw. Sealing. Although most believe hydraulic oil is what pieces of hardware such as O-rings, yoke cups seal against hydraulic fluid, especially oil, actually provide sealing within the internal components of pumps, valves, and motors as full valves. For example, a seal each in prevent oil from escaping the valve, but it's notch on the spool is sealed from the neighboring cavities by only the tight metal to metal tolerance and the oil surface tension and resistance to shearing. So mo ni kaning sealing, so mo ni siya mga kuan sample ani sealing mo ni mga O-rings, yoke cups. So ang hydraulic fluid pod mo ni mo provide siya og di bali sealing, mo provide po ni siya og kanang sealing para sa sa kanang sa sulod sa machine. So so kung wala ni lubricants kaning or hydraulic oil, mas prone kaning mga sealing nga mga bitaw. Malanay mo gunang mga niya mga sealing diya sa muna resulting na sa mag-leaking na. So makaning oil ay hydraulic oil, so isa ni siya para ma-minimize niya bitaw ang kanang pagbagid-bagid sa mga metal to sod. So next, lubrication is required in most hydraulic components to protect internal parts from wearing or even downright melting as a result of metal to metal friction. Oil provides full lubrication between moving parts such as slippers and lens plate of the piston pump. Without the lubricating properties of oil, hydraulic system would be terribly inefficient and awfully unreliable. So mo ni ang trabaho po sa hydraulic oil fluid is to lubricate sa mga components to sa sulod sa mga machine. So to prevent sa kanang mga metal to metal friction. So kung wala man gyud lubrication, kung kanang metal magsigig bagi-bagit, biya na mo baga, so ma-cause na siya kanang mo bulge ang yang metal mo burot, so mo stuck na tong mga mechanism to sod kay di na mao lagi ni burot ng metal. So mao ni ang purpose hydraulic para i-neutral niya ang heat, ang friction dito sod. So viscosity o pour point. The pour point of an oil is essential property that determines how it flow and at a given temperature. This is particularly useful for many systems where the temperature can fluctuate due to internal or external environments such as a car or aerospace engine. So kaning pour point, so mao ni ang kaning essential property sa to determine kung unsa kakusgo ang flow sa oil og ang given temperature. So maapektuhan man gyud ang temperature sa ay kanang flow sa oil kung sample init kay ang inyong environment. So mo na ang po na ang yang flow pod sa ang viscous po na sa oil maapektuhan pod og kana pong bugnaw makaapekto pa na. So mo nang kanang pour point mo ni siya ang property nga para ma-determine nato ang flow sa fluid. So what is pour point of an oil? Pour point of oil is very important property in temperature. This oil which the oil loses flow it has. So mo na niya ang giingon na. However, it is much more complex than that because the pour point is relative to its viscosity. Then the fluidic behavior of the oil also contributes to the obtained pour point values. Even if they are not being specifically deduced, the fluidic and viscous behavior is usually down to two types of viscosity which are based around shear stress and shear rate of the fluid. The two types of viscosity that contribute to the oil fluidic properties and the pour point are dynamic viscosity and kinetic viscosity. So the loss of flow of fluidic properties and its oil pour point can be attributed to either the loss of waxes from the oil matrix, more common, or because of strong influence from the viscosity properties of the oil. The latter is generally for more viscous oils. So next, for residual fuels oils, there is sometimes another reason where the loss of flow can be influenced by the thermal history of the oil. The amount of duration of heating and cooling that the oil has been subjected in its lifetime. For the pour point of an oil that is involved is a spillage, the size and shape of the container, the head of the oil, and the physical structure of the oil can also affect the pour point value. So, mo ni nagiingon dire nga mo ni mga maka-affect sa pour point value sa fluid. So analyzing the pour point of an oil, there are range of manual and automatic industry adapted methods that are used to measure the pour point of an oil, which are upheld and approved by the International Standard Organization ASTM International for measuring the pour point of the petroleum-based oils, and standard tests are ASTM D97 and ASTM D5949 for crude oils. The standard test is ASTM D5853. So mao ni ang kanang mga standard sa kuan pour point oil.
Environmental floods. The hydroelectric industry of increasingly moving toward to environmental acceptable floods. However, overall performance of most biogas has been disappointing. A key issue that floods compatibility such a yellow mental allows confidential consent texting such DIN 517559 ASAMD 130 copper description text as ASTM 2619 hydraulic installation text does not depend determine real world of performance. Pneumatic piping hose of connection. Hoses of tube that regularly use pneumatic system of this descript both but are different component of system. As a only hose descript but present error of content like accurator values. Pneumatic piping apply in the use to convert air from two basic reasons. The supplying energy that operation of instrument of other device, and number two, as transmission of information between instrument. Pneumatic piping. Integrity of piping system of its machine avoid loss to design supply and distributor of degradation submission equivalent disarm control and internal source of typical between 60 and 150 feet gauge. 400 to 1K PKAP should be clean, dry, and suitable the application of environment. Supply are actually delivery control system from external source of division typical between 60 and 150 PSA gauge. 400 to 1000 kPa should clean, dry, and suitable to application and environment. Connection permitting and part of use connect to selection pipe tube and hosting and pressure gas system. Compare the hydraulic fitting and typical characterized by technology's low pressure of requirements. Cleanser in general, device of reduced to precision flotation of therefore reduced noise produced and in connection with this without preventing and transport of fading. In halogen and silence is instead to reduce and pressure condition line and downless to pump to operate on waves possible frequency range. The apex of entire system must be considered such a silencer must be adapted of respective system in this common failure. Cause of air leaks. What causes leaks of pneumatic system? Pneumatic most often found the junction point between a system of use pneumatic application, especially around contactor joints fixing leak, and can be straightforward meeting up of connection or more complex replacement and faulty component like hoses, fittings, couplings, joints, pipe selection taps, and or drums. The connection are very large family of component used must house tube and for heating device. They not be chosen carefully and positioning ensure that look void and achieve and very necessary push-in connectors and very popular do of systematic and installation but may be prone as binding system and frequency and disconnect.
Good day, sir. Good day, students. I'm James Webster Montañez, continuing the report of Mulig Renz. The causes of air leaks. So isa po ni siya ang pressure leakage may also ensure if the pressure load on valves or connectors exceeds their specified rating. The flow rate of air depends on the pressure differential pertaining across a leakage point. So a lower overall system pressure will help reduce the rate of leakage. If you can stabilize the header pressure of the system at the minimum range that is practical, the leakage rate should also be minimized. So man isa sa mga kuan ang pressure mo ni dahilan po sa air leak. Next, too many connection nodes. So dagay mga connection. So however, carefully you seal your connections if they are pushed to function outside their pressure parameters. Some leakage is bound to occur. Furthermore, the more connections there are in the system, the greater the likelihood of multiple leakages, leading to a cumulative drop in overall pressure. Increasing the number of connections is not therefore a cost-effective way to expand your pneumatic system, as it also makes the system more complicated and more difficult to detect leaks. So grabe na kay mga connection nodes. Diri na maglisod na tag kuan detect sa mga mga leaks, mga air leaks. Next is wrong connection type. Thread types come in many varying styles and sizes and tend to differ according to their country of origin and use. Connections typically use male and female mating parts. So it's important to make sure that the thread types match. So muna importante po ni ang mga sizes sa yung mga threads kinahanglan sakto gyud pod para wala gyud malik. There are also recommended torque values for most threaded joints and connections. Connections should not be over or under tightened in relation to these valves. So dili daw kuno kay ba kuanan dili kayo luwag. Threaded joints should be secured with Teflon tape. Kasagaran nga ni gyud butangan gyud nila Teflon para gasog kuan wala gyud mo leak nga air. Next is seal degradation. Exposure of some materials to chemicals may make them degrade. Items such as rubber washers may develop cracks that allow leakage, or thread sealant might be of the wrong type. Ang mga kasagara og mura siya ma-worn out na ba yung mga kuan, yung materials may expose sa mga chemicals, na mga rubber nga washer na ma-crack na, wala na diya na gawas ang leakage sa air. Or thread sealant might be of the wrong type, o dili pud mao yung mga sealant nga kuan, or not properly applied, wala matarong og apply nga kanang mga sealant. All fittings, tubings, hoses, disconnects, etc. all should be of a high quality and properly installed with the right thread sealant. Mani kasagaran kuan kinahanglan sakto gyud ang atong mga gamit nga mga fittings, tubings ug hoses. Nya kinahanglan pod nga high quality gyud siya. Next is cylinder bore wear. It's possible for a pneumatic cylinder to suffer excessive wear on the bore if it doesn't have the proper lubricant. Mani kasagaran para sa motor gyapon nga bore, rana mo aso na kay wala tarong ang oil, walay proper maintenance. Mani kasagaran misalignment or improper mounting can also cause lateral forces to be applied on the bore. Mani kasagaran garas na yang bore, which could cause air to leak along the piston's periphery. Mani og sa motor pa nagbail ang oil dito na sa chamber na niya, combustion chamber niya ang mo kibali, og sa motor pa gyud mga makina ni siya loss compression ibali manang ang og diri pod sa kuan mga sa air leakage pod mao po ni kasagaran pod bore. Next is predictive leak prevention. Establishing a good leakage identification and repair program is critical to maintaining a stable, reliable, efficient, and cost-effective pneumatic system. Such a program should involve employee teams in the identification and tagging of leaks. Mani kasagaran kini mga para dali ra makuan, itag nila ang mga leaks, i-track nila, tracking performance, carrying out repairs and verification. Kinahanglan mag-verify nila, carry out nila ang mga repairs. Whenever leaks are identified and repairs instituted, the whole system should be reassessed. Schedule predictive maintenance can help you detect and deal with leaks so that you save on reactive maintenance and unscheduled downtime. An aggressive program of leakage prevention and reduction should therefore form part of overall performance improvement of pneumatic system. So kinahanglan kini og ma-identify na nila mga kuan, na-verify na nila ang mga kuan na mga leakage. Ana masunod the whole system should be reassessed na dayon. I-reassess na kibali dayon. Yang schedule predictive maintenance can help you o makadetect yun na dayon kining kinahanglan ma-predict yun nato dayon ang sagaran og sa ba dali na ba kinahanglan kabalo kas mga parts nga kuan kamus ana siya ma kuan mo worn out or sa ba. Next topic is hydraulic and pneumatic fuses. So diri, a fuse protects a system against component failures. So man kasagaran fuse mo magina siya. Protection is mga component ng mga failures. There are actually two distinct types of fuse and their operation and effects are totally different. So sa hydraulic mao ni nay duha ka fuses. Two types of fuses. The first type of fuse protects against the plant damage from over pressurization. Kini ang isa nga type nga fuse nga over pressurized na. Siya mo protect ani kung gabi naka pressurized ni kayo. Mounted for example in a line directly from pump outlet to tank, it is a simple thin metal plate which will rupture at a specified pressure. Mo ni kini nga mura siya metal plate mo rupture siya kung gabi na kay pressure mo buto kay bali ug sa kuan pa mo sana maguba. So ang pressure mo makontrol na gyud niya kay over pressured na kayo. Once ruptured, the entire pump deliver goes straight back to the tank. Ano siya ilargo puno niya sa tank ug mo ruptured, leaving minimal system pressure. Bumuga mo ubos ang pressure. Once this type of fuse has blown, the system must to be shut down. Kinahanglan ma-shut down. Murag silbi murag kuan na po ni siya warning ug kini nga fuse mo buto mo blown, the system must to be shut down and fuse replaced. Kinahanglan alisdan gyud ang fuse dayon. Note though that the sudden and catastrophic loss of pressure can cause unwanted movement and safety hazards. Mo ni kasagaran pod mo ni bantayan pod kasagaran kay napoy mga kuan delikado po kay ni ang kuan ng mga pressure daot pod ang mga makina. The second type of fuse is common in aircraft and mobile plant hydraulics. So ang second type kuno sa fuse common kuno sa mga aircraft ug mga mobile plant hydraulics and protects against a failure of a pipe of connection which results in a major leak. So kini nga kuan mao po ni maprotekta sa mga pipe or mga connection which results in a major leak kuno. It detects higher than normal flow in a line and shuts to prevent further leakage. So mo shut ni siya nay mga kuan nga mga pipes nay nagi-failed nga pipes mo shut ni siya kibali mo i-close niya kibali to prevent further leakage. So prevent niya ang kuan kanang mas grabe pa noon nga leak. Usually the fuse has to be manually reset. Kinahanglan i-manual ni pag-reset kung gusto nimo ni i-reset gyud siya. Although it does totally shut down one motion, it is probable that other motions can still continue allowing the plant to be brought into a safe state. Whistles working well for major leaks, they are not capable of detecting small dripping leaks. So kini sa mga major leaks regular siya din siya angay mga gagmay lang nga leaks di niya ma-detect. So back sa tagdali probable the motion can still continue daw gyapon mo continue gyapon siya sa uban parts kay mo. So pneumatic fuses also protect a pneumatic kini karon sa one of ni ang pneumatic fuses also protect a pneumatic system against major leaks. If a flexible hose for a pneumatic tool fails or a coupling becomes detached, the sudden very high airflow will cause the hose to trash around with the potential to cause major injury. So mo delikado po niya ni kasagaran yung mga flexible hose kini siya mo fail siya grabing hangin nga igawas kung makuha ng kini nga mga hose. Like hydraulic fuses, they have to be reset manually. Para man siya katong hydraulic nga second type nga fuse once basta ma-triggered na. So that's all. Thank you for listening and for watching our report. And that's all. Thank you.